Okay, we are going to get going. Thank you, everybody, for coming to this. This is going to be a lot of fun. We are going to go through a lot of material during this webinar. I'm going to fly through sort of three database designs that we do at LunaGeo Spatial that integrate PostGIS and QGIS. So welcome. Just a little background about what we do at LunaGeo Spatial. We are a GIS consulting and software development company located in London, Ontario, Canada, serving clients around the world. We specialize in open source GIS. We do consulting and training. We also do software development, building things like web-based GIS platforms, dashboards, data portals, things of this nature. And we also specialize in developing, maintaining cloud-based GIS servers. We offer fully managed, customized cloud-based servers that run things like GeoServer, Postgres, PostGIS. Along with that, we provide extensive backups, support, training, really everything you need to either migrate to open source GIS or use it successfully within your organization. So a couple of things to note. You can register for our newsletter. We try not to spam you. We send, one or two out every now and then. We try to do monthly, but sometimes that's just not possible, but that is the aim. So we try to include a lot of helpful information, upcoming webinars, things like this. If you're interested in any of our past webinars, I should note that there are a number of them online. We try to post all of our webinars on YouTube eventually, and you can access them from our website as well. If you're interested in training, we've recently launched LunaGeo Learn, which is our training platform that includes now 3 courses that are open to the general public. There's a couple of additional courses that are opened up to all of our server clients. If you have a server with LunaGeo Spatial, you're able to access all of the courses for free for however number of staff you have. Well, we usually limit it, but based on the size of your server. But you can have access to all of these courses and use them however you wish. So head over to lunageo.com/training to find out more about those courses. And I also mentioned that we do servers. If you're interested in pricing, we're very transparent with our pricing and the services that we offer with our servers. So if you're interested, head over to lunageo.com/servers and you can learn more about these. So the intended audience for this webinar. Really anybody who's interested in Postgres and PostGIS databases, database design for QGIS. So if you're using QGIS in an enterprise environment and you want to start connecting to a database, this is for you. And it really is an introductory overview of what you can do with these databases. So really, no experience, not a problem. And also, this is really for anybody who's considering migrating to open source GIS. So if you're using some other platform and you're thinking, can this do the stuff I need it to do? Can it create that multi-user editing environment that I need if I am going to migrate to open source GIS? So this will give you a hint to what you be able to do if you do make that migration. So note, this isn't a complete course on database design or data management. This is really intended to be an overview of the subject. So the outline, we are going to talk about, I'm going to give a little introduction, then we're going to talk about asking big questions. We're going to talk about Postgres database design conventions, and then we're going to talk about the 3 databases, the vector data warehouse, the replicated project, the centralized project, and then we're going to conclude the discussion. All right, so let's dive into the material. All right, I should say before we get going is that the Q&A is open. I probably won't answer questions during because it'll be distracting. The chat is also open. Probably won't answer questions during because that'll be distracting. But I will get to them at the end. We are going to do a Q&A at the end. So if you have any questions during, feel free to drop them in there. But I won't look at them probably until the end because I find it a little distracting when I'm jumping back and forth. All right. How should we organize data? Well, I often think about books. And I think about how we organize books. How can we organize books? Well, we can organize them by genre. We can organize them by subject. We can organize them alphabetically, either by title or the author's last name. We can organize them chronologically when they were written. We can use some sort of standardized system, some sort of library system to organize our books. We can also organize them by size, by color, and usage preference. So we can put a bunch of our reference books on one shelf because we want to be able to grab those all the time. So let's think more about data. So how many ways can we organize data? Well, we can organize them by themes, data types, intended end users, intended usage. Data security also comes into play when we're thinking about how we're going to organize data. So the big thing we have to think of, and what we do with most of our clients when they come in and they say, we want to move towards open source GIS, we want to move our data into a database, we want to set all this up, is we have to sort of pump the brakes a little bit and say, let's talk about a spatial data management plan. We need to figure out the data governance framework. We need to talk about data architecture. How many databases are we going to have? What are we going to put in these databases? What are they going to be used for? We're going to talk about naming conventions for databases, tables, columns, and other objects. We're going to talk about standard coordinate reference systems for spatial data. We're going to talk about data security to define data access rules, group roles, end users. This often becomes, this is really part of our implementation process when we set a client up on a cloud-based server. We go through all this. We talk about who should have access, how should they have access, what are we building here? We talk about data backup plans and disaster recovery plans. And we also talk about ethical and legal compliance if necessary. So if you're pulling in something like third-party data into this server, are we breaking any rules if we're resharing it out to some web map application? So this is really part of the discussion that we have when we're first implementing a client. And then the dirty subject of metadata strategy. How are we going to record, preserve, share metadata related to everything that's within our databases? So to do this, we have to ask some big questions. So client will come up and say, I need a spatial database. That's wonderful. That's our starting point. But we need to ask these 5 big questions. The first one is, why do you need a database? What are you planning to store in the database? These 2 questions kind of go together. So why do you need a database? What are you moving from and towards? What are you actually going to be storing within this database? What kind of data? Is it all spatial data? Is it spatial? Is it tabular data, non-spatial data? What are we needing to store? How is it going to change over time? Are we going to be editing it? So then this comes up to question 3, like who will access the database and what will they do with the data? Are they going to be editing? Are they just going to be accessing it to read it? Where will you access the database? Always a very interesting question, right? Because we need to, especially when we're talking about cloud-based servers, when we're implementing this in any data center around the world, where will people be accessing this database? From their home, from within an office? Are we going to be setting up a VPN? Network security comes into this when we're talking about that question. And lastly, and perhaps most importantly, is how will the data be accessed by users and other applications? Are you going to be connecting just with QGIS and connecting directly to PostGIS and pulling in data? Are you going to be connecting with pgadmin? Or do you have some web application that's going to be pulling the data? Are we setting up an API just to tap into this database to do some sort of spatial function and spit it out onto some sort of web dashboard? So all this comes into play. We need answers to these questions. We need to figure out exactly what you need, because just having a spatial database is not enough. We need a plan. We need an idea of what we want to build. So Postgres, there are some design conventions when you're putting up a database. There's some hard and fast rules. There's some things that are set by default within the database management system, and then there's some things that we just do here at LunaGeo when we're setting up a database, just for consistency's sake. So I'm going to run through a bunch of this. Some of this is stuff that we just do. Some of this stuff is in the database. Some of this stuff can be changed in the database if you want it to, So let's dive in. So when we're talking about database names, so we're going to talk top level now. So we're going to talk hierarchically now. So database names, it must be unique within the database server. You can't have two databases called GIS. It's best to use lowercase snake case. I think I see a few of our clients on the list here, and I think everybody knows that I say that all the time, lowercase snake case for everything. Let's not have anything else in a database name, a table name, or anything. So I say this over and over again, and I'll say that a lot today. Cannot start with a number. The rule is best to be short, but long enough to be clear. So there's no reason to truncate a word or use some sort of obscure acronym when you could just simply write out the word and use that for the database name. That's fine. Be consistent. If you're going to call one database projects underscore 2023, maybe make the 24 one be projects underscore 2024, not just projects 2024 without the underscore. And when we're talking about names in the database, so all database objects use the name type that's stored within Postgres. So we have schemas, tables, column names, and they all adhere to these rules within the database. Maximum 63 characters long. I've only ever hit that max once, and when I did, I realized that probably wasn't a good way of designing these names by the end. Cannot start with PG underscore or a number. Must start with a letter or underscore. So you must not use reserved words like create unless you're using double quotes. But then please take note of my next point. Best practice, avoid naming anything that will require using double quotes. Again, this is more of a convention within our company, and a lot of other database designers and managers do the same thing. It just makes for cleaner SQL in the end if you don't have a bunch of uppercase, lowercase letters, and spaces within your object names. Schemas. So used to organize database objects. They contain tables, views, functions, etc. Schemas are, I always tell clients this when they're new to database stuff, schemas are like file folders for database objects, but they're not really like file folders because you can't like put one schema inside of another schema. So then that whole file folder analogy kind of breaks down once people start asking for things like that. Use full words as needed. So you can see in the example here, infrastructure and utilities, that's fine. That's a great name for a schema. You know exactly what's going inside of that schema. Use, again, lowercase snake case to make us happy. For tables and column names, again, you guessed it, use lowercase snake case if possible for table and column names. Oops, sorry. Give tables suitable names and use full words. You can call it the samples table. You don't need to use some strange short acronym, SNPLS or something like that. You can just write the word samples. It's fine. There's rarely a need for abbreviations in table names, unless you're using something that's incredibly long or some writing a sentence there for the name. You can just pretty much call it whatever you need to call it. Don't start table names with TBL underscore. This used to be done in the past with some database management systems. We know it's a table. It's fine. You don't need to identify it as such through the name. Always call the geometry field geom. There was always a lot of documentation online that would call it the underscore geom, and then people started naming their, geometry fields in production, the geom, and chaos ensued. Just call it geom and the world will be a happier place. Units of measurement, sometimes I put these in here, sometimes I think maybe that's bad in case they transform to another database system or something, or another coordinate reference system that's not in meters and now it's in feet and we're preserving this, and maybe it's a bad idea, maybe it's not a good idea, especially if it's a trigger function actually populating this, but I do it. So if we're in UTM, I will add the unit of measure like area SQM or square meters or length underscore M for meters. I might, convert that to kilometers in a trigger function, and I'll actually put kilometers in there. Foreign keys. I always tend to append underscore ID to any field. So you can see here the sample type ID. field that's here defined as an integer. That's a foreign key to a table that's called, you guessed it, sample type. So by appending the ID at the end, it's sort of just an indicator to us that, oh, this is going to actually refer to some other table and will refer to the ID field of that table. I prepend for FK underscore to the name of that field in order to indicate that this is the foreign key that applies to that field. And you can see that here. This is the name of the foreign key. The foreign key field is defined here, and then we're referring back to the table. Now, if possible, name lookup tables based on the foreign key fields. I do this a lot, where we'll create a lookup table that refers to another table, and we will call the table, you guessed it, sample type. And the field that will store the list of sample types will actually be called sample type, and it's a not null field. Trigger functions. We have some rules as to how we do trigger functions. Again, naming using lowercase snake case whenever we're defining these functions in the database. We put generic trigger functions in the public schema so they're accessible to everyone. If the generic trigger is used, try to use the same column name in each table that uses the trigger. So this goes back to, naming things area underscore SQM. If in the water body table you call it water body area SQM, then it's going to be just a little bit more work to make that trigger function work against that field itself. So I tend to just try to be consistent. If I have some sort of area calculation trigger function in the database, I'll just call it, the field area SQM, just to make the world a happier place. Put schema specific trigger functions in the schema where the referent table resides. So if you have some table and you're doing some sort of complex trigger function against that table and doing all kinds of crazy, wonderful spatial analysis, when you lay a point down, maybe store that trigger function in the same schema. There's no point in storing it within the public schema outside of the database. Okay. Database design 1, the vector data warehouse. So it's a big name for something that's just going to be your standard database, right? Think of it as just a central repository for all your vector data. It's typically used to store open data and other enterprise-wide data. We have a number of clients that produce their own data. So once a data set is ready to be used throughout the organization, then it goes on to this GIS database, and then everybody can see it and access the data set. Likewise, open data, tons of clients are pulling open data. State, provincial, federal data is pulled in and loaded into this centralized database. It leverages various QGIS integrations with PostGIS, and we're going to go into some of these. So this is typically what it looks like. We'll set up the GIS database with a number of different schemas. The schemas are used to categorize the data. So we have things like boundaries, cartography, demographics, ecology, and so on. You can probably guess what types of tables or layers would appear within these individual schemas. So something like a boundaries schema, we might put something like upper or lower tier municipal boundaries, or even city boundaries might exist here. In the hydrology schema, we're going to put things like water courses, water bodies, wetlands. And in something like maps, hydrology, it's pointing to the wrong one here. We're going to be this is actually just copying. Look at that. There's a mistake. But in the map schema, we'd be putting something like, that's where our actual QGIS projects would be stored. And in that, we'd be able to save all of our map projects directly in there, and they'd sort of serve as like templates. Naming conventions are important. You notice here that I'm using lowercase snake case when I'm naming any of these tables, and I'm calling it upper tier municipal boundaries underscore Ontario for the province of Ontario. And I'm also doing like London city boundaries here, where I'm just sort of defining the location as well as the data type. I try to put the theme first. I try to do something like water courses underscore and the geography of the data set itself. But you might also include things like location, scale, some sort of date or timestamp if that's important to the data set. and the data producer owner. I think the key here is just to try to be consistent when you're loading and naming data sets in the database. All right, QGIS integration. One of the tools that you're going to use the most when setting up a database like this is the export to Postgres tool. It is really nice. I consider it the best tool to load spatial data into Postgres, PostGIS. It's just a GDAL tool. It's just a sort of wrapper for the GDAL command line functions. You can load into specific databases, so you can sort of define the database and then define the target schema within that database. One of the things I really like is you can reproject. So when a client supplies you with a ton of data and a whole whack of different CRSs, you can just reproject it as you're loading the data into the database. You can rename tables. That's right here. So if the table is not in lowercase snake case and you want to rename it as such, you can do that here within the tool so that when it is loaded into the database, it's going to have the right format for the name. You can also automatically create the primary key. The only trick here that I always say to people, I'm like, if you have an ID field in the data set and you don't need that ID field and it means nothing to you and it's not going to mean anything to anyone, drop the ID field or rename it or something, ID old or something. And then allow this tool to create that new ID field. You can create another ID field, but I guess that's another thing that I do to be consistent. I try to make sure IDs are always called IDs, or primary keys are always called IDs, I should say. I like using the batch. You can run it as a batch process. I will often do that, and when I'm building a very large database, I tend to do that on my local host. I build the database, I load up all the data, and then I'll run a backup and restore it to a remote database server. Symbology. If anybody has ever watched any of my previous webinars, I talk about symbology and default symbology. So one of the things that's really nice about QGIS is that you can save default symbology within the database. That always comes in handy. Be consistent. It allows you to have this enterprise-wide symbology. So if anybody loads the watercourse layer, they're going to load the watercourse layer with the exact same style, the exact same labels. The other thing that I really like is saving projects to QGIS. So you can save various QGIS project templates in the database. And you'll get what I mean when I say sort of project templates when we talk about permissions in a bit. So keep in mind also that projects are much more than just a bunch of layers sitting on a map. So projects are all your styled vector layers that you've loaded onto the map. Any WMS or XYZ tiles or anything that you bring into the map, load into it, that gets saved into the project. All of your print layouts get saved into the project. Things like your spatial bookmarks can even be saved into the project itself. And if you've created any custom processing tools, you can save those to the project as well. So think about this for a sec. So now we have a database called GIS. We have a whole whack of data in it. We've organized the data into various schemas, and then we've created this template base map QGIS project that now lives within the database. You can put tons of stuff in there. You can put things like processing tools. Your users can then open up this project, save it locally, and modify it however they need. They can just open it and open up the print layout, zoom into an area of interest, export that as a PDF, and they're done. It's a really powerful thing. So another thing that we do often, and this is just a little tool, but it's really kind of handy, is that once you've loaded a ton of data into one of these databases, you want to be able to find the data. So naming your schemas accordingly is your first step. So if you're looking for a boundary, a boundary file, chances are it's sitting within the boundaries schema. But you can also easily locate layers using the filter function in the browser panel. I really like to do that. You can just type in sport, and all of a sudden you're finding the layer that's called sports association. So you can search for layers also across databases. So if you have a layer that, a table that meets the criteria, your search criteria here, you will see a list of multiple databases, as long as you have connections, of course, to those databases set up in your browser panel. So let's talk about permissions for the GIS database. So the administrator role can upload new layers and modify existing one. We of course need this role. They need to have full permission. So we need to grant all on all the schemas. Here's just an example for the boundary schema, of course. And you want to give them full permission over the whole database and all schemas therein. Now the read-only role, and really anybody else, shouldn't have access beyond read-only. So they should have usage access on the schema. They shouldn't be able to create anything in this database. And they should have select on all tables. That's it. Nobody should be editing this stuff because it's third-party data, possibly, or internal data that you don't want somebody to be modifying. The only people who should be modifying this database are the administrators within your organization. So a couple of things to remember. The goal with the GIS database is to make data easily accessible, so organize things. Restricting edits on data is critical, especially, as I said, with third-party data sets. Something to also note here is that these databases can get really large, especially if you're loading data for, an entire province or entire state or the entire country. If you're not updating this stuff on a very regular basis, your strategy could be a little different for backing up this database. You may not have to do a daily database backup for this database. Maybe once a week is fine. Maybe once every 2 or 3 days is fine. Plan ahead. Avoid changing the database schema or table names or moving data between schemas, or dropping tables, I should add. If let's say you have something that updates frequently, like a cadastre data set. So if you're loading all these parcels in, and then one day you're going to say, you know what, this is the data set for 2022, and now we have the 2023, and we're going to have the 2024. Don't drop it, because just keep in mind there's going to be users throughout your organizations that are referring to these data sets in QGIS projects. So if you change the name or anything, yeah, you can remake that connection in QGIS quite easily, but it's still going to throw an error. And in my experience providing support, you throw an error to a user and people are going to get mad, and they're going to not know what to do, and they're not going to know what buttons to press. So it just means it's an additional service call, and it's an additional little bit of hand holding that you really didn't have to do if you just didn't move or rename or delete a table from this database. Load what you need. If you're only interested in the city of London, Ontario, and you're never going to be doing anything beyond the city boundaries of London, Ontario, there is no point in loading data beyond that point. Feel free to clip and load. Set scale visibility. If you're working in a very large area, I have a client in British Columbia that loads all of the elevation data for BC, and if you know anything about British Columbia, it's a little bit hilly. So there's a lot of contour lines. Loading all of those when you zoom out to the entire province would just grind everything to a halt. So they'll only load in that we have scale dependency, so it's only going to load in as we zoom in. So just think about these things. All right, next database. Database design 2, the replicated project. We do this a lot. This is one of the ones that we do quite a bit. Probably just about as much as building that sort of data warehouse model. So a project template is designed and replicated for all new projects. So this is for an organization. Think of it as like a consulting company or an agronomy company, or an environmental monitoring company that has to have a series that does a series of projects throughout the year. We also have archaeology companies that we work with who use this model. So the template is also included in also includes a QGIS project, and that QGIS project is replicated whenever we create a new project. A custom plugin can be used to create new projects. This is what we do for most clients, is once we figure out that initialization script, we turn it into a plugin where literally you can just press a new button. If you're an authorized user, you click a button and say new project, and a new schema is created with everything you need within it. Default symbology is replicated for all new projects, and that's really kind of cool, and I'll show you how we do that. All right, this is what it looks like. So we have our database server, and in the server we have a number of schemas. I'll get to that in a moment. And we have a GIS database that contains all of that base map data. And then we have a whole bunch of other databases for previous years that are named consistently, projects 2020, 21, 22, and now we're in 23. So the schemas. So the schemas here are going to contain, it's possible to, we try to avoid exceeding about 200 schemas. It just makes it a little slow to load and to back up and to work with a database. So it's not a hard and fast rule, but it's just something that we sort of noticed, like, things start to get slow as we get up to about this mark. So we try to limit it whenever possible. Now, there might be some disagreement on that subject. I don't know. It might depend on a bunch of other factors too, whether or not it gets slow or not. But that's usually kind of the rule that we stick to. So Project 2023-1 Franklin Farm schema. So you're going to notice that it contains 4 different tables. It contains a boundaries table, a field access points, and a soil samples layer, as well as the QGIS projects table. Now, when you look at the Vasquez Farm schema, you're going to notice it has the exact same tables. It has the boundaries, it has the field access points, it has the soil samples, and it also has that QGIS projects table for whatever projects you're going to create within that project, within that schema. So this is a nice way of doing it, but what if we need to do any type of spatial functions with the data that's sitting in the GIS database? There's a couple of options there. One, we can do something called a foreign data wrapper, where we actually load data from the GIS database into the projects database and have it look and feel and act just like it exists within that database. Then we can run spatial functions against it. And then the other option is that we do sometimes is we'll just create a reference data schema. And if it's something that doesn't change a lot, and you know what, it's a lot easier just to load this reference data. If it's something like, I don't know, provincial boundaries or something like this, or county boundaries, they're not really going to change. Let's just sort of load them in. Then we'll just load them into a reference data schema. And whenever we need to do a trigger function or something like that, we'll actually use that instead of a foreign data wrapper. Okay, so some of the QGIS integrations that we do when we're setting up a database like this is to the replicating of the default symbology. This is really cool. So if you don't know much about how this is stored within the database, it's basically stored in a layer styles table that exists within the public schema of the database. Nice thing here is that we can go in and we can make copies of that. So if we have a template schema, as we do here, you can see the schema name is called template for projects 2023. We can copy that. So we can take that, we can take all the styles that are applied to the template schema, make a copy of it, and reinsert it. So we just write a very simple sort of SQL statement. It's just an insert statement. So we just insert from the database and we put that new project name here. So when we're creating that new schema, any layer, all those layers that we create that have the exact same name as the one in the template schema, will actually pull that style, that default style from the database now, because we're just replicating what exists within that template schema. Okay, the other thing we do is we create a custom plugin. So really not much to this, except we write our SQL scripts and we turn this into a Python script, and then we turn this into a basic plugin that can take a couple of inputs and then pass them on to the script. So it creates a new project schema. So if your new project is called Patterson Farm or something, it creates a new schema called Patterson Farm. Then it creates all the project tables. So it renames the tables as such too. So if you have fields, you have like fields, Patterson Farms, whatever project, and that's going to be created within the schema. So now we have the tables, we have the schema, that's fine. It creates the default style. So it runs that SQL statement that you just saw to create the default style. So if anybody expands that schema and tries to add any of those layers, it will already have the default styles associated with them. And the next thing is really cool is we take, because QGIS projects are nothing more than XML documents. So what we do is we take the project that's within the template schema and we modify it. And we modify it to, instead of pointing to the template schema, now that project points towards the new project schema. So the last thing we have to do is change those default permissions. It's not really the default permissions, just the permissions on that schema itself. So if we want every editor within the organization to be able to edit that new project, then we set the editing permissions for that new project. So this is always stuff that's all sort of predetermined when we're designing the plugin. And it's also possible to create project variables for things like print layouts. So we do this a lot, where we'll actually modify the project variables within QGIS when we're creating that new project. So that if you are going to do a print layout map, all of a sudden now Patterson Farm is going to appear on that map, as opposed to, insert map title here. And this is really all it looks like. Another nice aspect of doing this with a custom plugin, this is it, is that we can identify the Postgres connection that we're going to use. We can identify the project name that we're going to use, and we can enter the new project name here. And we can also define the CRS for the project. So if we want to change it, we can. We've done a lot of things with this too for other clients, where we've done things like, prevent the user from putting spaces in the project name, prevent the user from using uppercase letters, or just automatically turning things into lowercase if they do put uppercase into here. We've also created a number of different fields. So you might have the name of the schema and the name of the that you're going to use for naming of the project objects within the database, but you want something that's going to look nice, like what's going to appear on the map layouts, the print layouts. You might have another field where we can insert that into here. All right, database level permissions on this database. So for administrator users, of course, they have access to everything within the database. They can create new objects. They can do everything they need. Editors and read-only users, they only have connectability on the database. For the schema and table level permissions, editors, obviously admin have access to everything. They can do anything they want. So for editors, they have usage on the schema when it's being created. They have access to all tables, so they can edit, they can delete, they can truncate, they can do anything they need. And we can modify that based on however we're implementing this for a client. And they can also execute functions, and they can use sequences. Read-only users, they have usage on the schema, of course, and they only have selectability on the data sets. So the nice thing is that when we create a new project, you don't have to then go back and say, oh, I need to establish permissions for this new project that I just created because Julia can't open anything now, and I just created it. It's all just done automatically, because it's the new project is only created by an admin who has the ability to grant these privileges. Things to remember. Really think about how you want to organize the permissions for a replicated project. It can get complicated. It can get it can get quite granular if you let it. The other thing to note is that you can revoke privileges. You can sort of give everybody the ability to edit a project as it's created, and then go in and say, you know what, okay, this project's done, nobody can edit this anymore, so that nobody can go in and sort of make mistakes. The number of project schemas, as I said, try to keep it to about 200 or less. This is a long conversation I have with clients. If they tell us we have 2,000 projects a year, that's significant. We're going to have to think about how we're going to manage this in the database, especially if we're doing one schema per project. If I have a number of clients who have like 70, 80 projects a year, that's fine. A schema per project, it makes total sense. We name the project according to whatever contract number they have, plus a couple of words to make it easy to find. But then we also have multiple years, and we'll say, okay, well, we're going to put all of your 2023 stuff in one year, and then we're going to have a new database. But even then, creating that new database has to have some sort of initialization script. So we have to go in and define that as well, or else it's going to be hard to actually generate that new database. We have to make sure like reference data and stuff like that is already in there and ready to go. So, and then the other big question I was asked is like, are you going to be executing spatial queries against data in the GIS database? If the answer is no, not one bit, all we're going to be doing is loading stuff and using the database as a place to store our data. Okay, that's great. We don't have to. And like, are you loading GIS? They're like, yeah, of course we are. We're just loading it on the map. That's fine. You can have multiple databases connections, load the GIS data from the database, and load your project database from the project database, and we're all happy. But if we do need to think through something like a foreign data wrapper, or even having a special schema for reference data, we usually dive into that with clients as well. All right, here's the big one. This one can get really complicated. We've done this a number of times, and it's always different. I think every database I'm showing you today, we do it. I'm showing you kind of like a generic version, but we usually, this is our starting point, and then things, get more complicated as we go on. So the centralized project. This is the big question that comes up. What if all project data must live in centralized tables? So an overview of this. So in the centralized project database design, all projects access and edit the same central data set. So imagine that you have some sort of like soil samples data set, and it lives in one table, and all of your QGIS projects are accessing that one soils data set. Every time you collect new soil samples, it goes into that same soil samples table. So that if you were to load just that soil samples table, you would see like soil samples for across Canada, because you've done projects across Canada, and you could see where you're sort of loading these samples. We have a number of archaeology companies that we work with who do this, right? It's an excellent idea to sort of load everything centrally. Now, database people will, come and say, well, you could do the same thing with views, or you can create a materialized view, and you can change the definition. Every time you add a new project, you can add a new line to the definition of that view to pull the data from that other table, that other standardized table, and pull it in here. It gets large, especially as we have multiple databases and we're pulling things around, foreign data wrappers. This is another option. Now, initially, when I designed databases like this, it makes me feel a little uncomfortable, because I thought, well, is QGIS going to slow down? We did a lot of testing with this for one client, and we sort of figured out that they're going to have it like 10 million points eventually within the database plus. For that, can we filter? And the answer is yes, we can, and it works fast and it works great. So I'm going to run you through this whole process. So there could be hundreds of projects that load and edit the data from these same central tables. So in order to get around this, we're using extensive use of filtering within QGIS to allow us to only load data for one specific project. So let me show you how we set this up. So in our database server, let's just say we have two databases. We have one called projects, and we have our one called GIS, which is our vector data warehouse. So the schemas themselves, if we're going to be looking at the project data schema, so that contains a table called projects that just lists the number of the projects and gives project codes for each. We will have samples. We will have fields, we have wells, whatever we have, right? So as we're collecting data, everything's just sort of going into these are our central data sets. So each table contains a field called project code, and that's important. And it has to be, there's a not null constraint on that field. And there's even a foreign key on that field that refers back to that projects table. Now, we might have some sort of lookup schema just to that we might use for value relations within QGIS. So if you've ever built something like a QGIS attributes form, I did a webinar on this a couple of years ago, I think. So it's on our YouTube channel if you want to check it out. But you can create custom forms within QGIS, which can be quite elaborate. There can be like conditional logic and everything in it. But one of the nice things is that you can just have these drop-down menus, and what color do you want? I want red. And red is actually being pulled from a table, a related table of colors, and red, green, blue, and they each have an ID associated with them. So that's where this type of data is going to live. If you have a list of provinces or a list of states or a list of counties, it's going to live within the project lookup. Now we have our projects 2023. Now, the interesting thing here is what lives in that schema. Only one table, and that table is the QGIS projects table that gets created whenever we save a project to a schema. It gets created by QGIS. This is one of our important integrations here that we're talking about. Basically every project is just going to be pulling the exact same tables into it, but obviously you're going to be zoomed into a different project area. Now, the same foreign data wrapper can be set up when we want to pull data from the GIS database. We can also set up that reference data schema if we want. We really have to determine what is needed in terms of access to related data. So filtering is important. So we can filter project data layers in QGIS so users can see data related to the current project. So imagine this, we've created a samples table. It's not very complicated. It has an ID field, which is the primary key, a geom field, which is nothing, it's just a point. We have a project code field, and we have a sample date, and we have comments. So in QGIS, this is what it's going to look like. We're going to have project 1 on the left side and project 2 on the right side, and a series of points that we've collected for both. And for that project code field, we're going to be entering either project 1 or project 2 through a drop down that's actually a related field. And then our attributes table is going to look like this. We're going to have 12 rows for the 12 points that you see on the map, and we're going to have that project code. We're going to have project 1 and project 2 within that field. Now, what's nice is that when we're setting up that project for project 1, and by project I mean QGIS project, we are going to set the default value for the project code to be project 1 for every single layer that we're going to be editing. Now, we're also going to be turning off the editability, so we're not going to be able to edit that layer. And by doing that, this is actually checked, but it would be unchecked. And by doing that, when the user adds a new point, they're not going to be presented with the option to change that. It's just going to be taken for that project. So you're not, in other words, you're not going to turn around and edit a point and then put in a project code that is some other project, because the minute you do that and you press save, it's going to disappear because you have filtering set up. And that's the next part. So when you load the layer, you go into the property, right click on the layer, and then you can go into filtering, and you're going to filter the layer. You're going to filter the project data layers using the project code. And that's what you see here is that project code ID. It's actually not underscore ID, but just project code is project 1 and so on. And you're going to save each project as a separate QGIS project in the database. So now we have a project called QGIS project called project 1. All right, so let me show you what this looks like in the end. In the end, we end up with a QGIS project called project 1 that has a bunch of points in it. And then we have another project saved in the database called project 2. And that has the other points that we want to see. Now they're being filtered. So we're not loading all the data and only displaying these points. We're only pulling these points from the database. So if your database ends up having like 10 million points in it, that's not a problem because you're only pulling in 12 points. So when we go to edit the layer, edit or add a new point, let's say to the map, you're going to be presented with a form like this. And you see that we can't actually edit this, the project 1 here. This is just going to be in project 1 because anytime you lay a point down, edit a point, create a point, modify a point, you're always going to have, you need to have project 1, or if you're referring to the project 1 or the project table, that referent has to be in there. Okay, same thing with project 2. Project 2 is going to appear whenever you're creating a new point. So permissions can be fairly simple, or they can be very, very complicated. So let me go in and show you the simple way. So the simple approach grants all on all project tables to all editors, which is fine. Now, this comes with some security risks. So every editor can now access and download all data that your company, your organization has collected within these tables. So if you have 10 million points, every single person in your organization has the ability to load all of those points in QGIS and save them and make a copy of that. Or anybody else who sort of hacks into your system will have access to all that. So every editor could also delete all data. Now, if you have a good backup strategy, shouldn't be that much of a concern. And the other thing too is don't forget that when you have individual schemas per projects, your editors, if they have full permissions on all those projects, they could also go through and just sit there and go delete, 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 delete. But these are just some of the risks to be conscious of, is that instead of that one mistake impacting one project, that one mistake can now impact all of your projects within your organization. So we do have to think about what permissions we want to give those editors. We don't want to take delete away. Maybe we should take truncate away. I do that sometimes. And this is kind of what it looks like for the editors. If we're going to give them all permissions, these are the privileges. We're going to grant usage on the schema. We're going to grant all on all the tables. We're going to grant execute on all of the project data, and we're going to grant usage on all the schemas so that they can create additional rows. Now, some of the more advanced permissions, what if we don't want to give all staff access to all project data? So this came up recently with a client, and we sort of got down the road and we thought, oh, shoot, you know what? That is going to be a problem. And that's something that we need to address. How are we going to do this? So step one, we associate users with a project in a project table. Step two, we use row level security rules to grant access at the row level. So then at that point, we can say, you know what, this user has access to this row because they're listed as being part of that project on another table. And I'll show you how, I'll give you a visual of how this kind of works. Okay, so here's our table. We have our 12 rows that have points for project 1 and project 2. Now we're going to create a new table, and we're going to call it the projects table, whatever we want to call it, projects. And it is nothing more than a list of all the accepted project codes that can go here. And you guessed it, there will be a foreign key. So the foreign key is going to be set up between the projects table and that project code field within all of your project data sets. And then we're going to create another table, and we're going to call that project users. And this is going to also have a foreign key that refers back to that projects table, because we are now going to be listing the users by name in one field, and we're also going to be listing the projects that they're associated with. Now, something that I don't mention here, but that's important, is that who should be able to edit the project users table? I'll tell you right now that it shouldn't be anybody with editor privileges, because then if you're an editor, you could just go in and say, I don't have access to this project. I'm just going to add my name to this list. And think of this as just that. It's just a list of saying, okay, this person can access this project. This person can access that project. So the only person or the only users that should be able to edit that table and the projects table are the admin users within your organization. So this is where row level security comes in, is that we're then going to have that table that defines who can have access to what. If your name is not listed in the project users table, even if you're listed as an editor and editors have like access to everything within this table, if there is a row level security rule in place that refers back to this table and says your name has to be on this table in order to access this, you're not going to have access to anything. You're going to load the layer and there will be absolutely no rows within that table. So only users in this example that I'll give you, so only users Elsa and Anna can access project 1. Whereas only users Olaf and Christoph and Elsa can access project 2. So in this scenario, Elsa is actually added to both projects. So if we were going to go back to the project users table, we would see an entry for project 1 for Elsa, and we would see another entry for project 2 for Elsa as well. Whereas if we looked at Anna and looked in this table, we only have a reference to project 1. So when Anna loads this data set, let's say it wasn't within a QGIS project, there were no filtering put in place, but just drag it into QGIS from the database directly, she would only see the first 5 rows, whereas Elsa would see 12. Now, conversely, somebody like Christoph would only see rows 6 to 12 within the database, would have no idea that project number 1 even exists. So this is really powerful stuff, but it takes a lot of thought and it takes a lot of planning to set this up. I'm showing you a very simplified version. When we set this up recently for a client, we actually had additional tables set up for different roles within the database. And we also wrapped this all around a custom QGIS plugin because it was way too complicated to say to people, okay, when you're starting a new project, add an entry in the projects table and then add an entry into this table and then automatically add all of your project managers into the project users table. Instead, we automated that process. We just create a series of buttons, just like the last plugin you saw for the create a new project button, opened up a form, create a new project, put in all the information you need, and boom, like magic, you have a new QGIS project, and you have all of the data needed, or all the users who need access to the data have access. All right, things to consider. What is the plan if a project requires additional layers? We need to think about that. Where are we going to store them? Where are we going to put them? We don't have a project per schema like we did with the other database. Now what's going to happen if we need to have access to additional layers? Permissions can be very straightforward or very complicated with row-level security. So we do have to think through that process. Who will create new projects? Will they do it manually, like I just described, or are they going to be doing it with some sort of custom QGIS plugin? If a plugin, let's think through that process. All right, we're getting close to the end. So conclusion, do you want your database to look like this or this? And I think that's the big question you have to ask yourself. I think a lot of our clients move from a file system to a database. We have to create a plan. And so just some take-home points. Create a data management plan. Figure out how you're going to organize your databases before you start doing it, because it is very sticky. Once you start naming data sets and people start loading them into QGIS projects, you're sort of stuck with it unless you want to get a lot of people mad at you. Decouple your base map and your project specific data whenever possible. If you're able to do that and just have a repository where you're going to put all that government spatial data that you're pulling and updating, keep it in a separate database and put your project database somewhere else. Have a plan and be consistent with all naming. This is really hard, but maybe it takes, doing some auditing every now and then just to make sure that people are sticking to the rules that you've created. There's also some database tricks that we can do to sort of make sure that those rules are being followed. Keep it simple. It makes a lot more sense to split things up into different databases than it is to just sort of throw everything to one database and create a very complicated structure. Think about how the data will be used. Who will be using it? How will they be loading it? What kind of spatial work will they be doing on it? Are they going to be running spatial queries in the database? Are they just going to be doing work directly in the database itself? As I said, I keep on saying it, develop multiple databases. If you need to, put things in separate databases as it makes sense. So one of the things I wanted to mention too, that it's kind of important, if you're thinking of getting into PostgIS, our pricing, we're very transparent with our servers, and when we set them up, we publish all of our pricing directly on the web. Something to note is that we recently launched our micro GIS server, which is nothing more than PostgIS. It's a smaller server. It's great for learning, good for very small teams who might not need a lot of support or just want support when they need it. But one of the neat things about this is that I mentioned earlier that we provide access to all of our courses to all of our server clients. So if you are a server client of ours, you get access to LunaGeo Learn. So instead of paying $199 a course, if you spun up a micro GIS server, you would sort of have access to all of our courses for 2 accounts within LunaGeo Learn. So if you want to get started with that, head over to lunageo.com/servers, or you can email me directly at cpatterson@lunageo.com. You can set up a meeting, have a little chit chat about what you need. But it's really a great way to get started. We can spin up servers pretty much anywhere in the world. And with that, I will open up the questions. We're sort of running late right now, but I will try to run through a few of them. Give me a moment. Brian, you caught me. Why do we use, the question is, why do we use geom as a geometry field name when we should avoid using abbreviations? I think geometry is actually a reserved word once we have PostGIS installed, but that's really a good question. That made me laugh. Thanks. Yeah, it is an abbreviation. I apologize, but that's pretty much the standard that we use for naming that field, geom. Okay. Okay, so if the data is, oh, Bernie, hi. If the data is just for serving data, so I guess if the database is just for serving data via OGC services, is PostGIS the best, fastest place to store the data? Would GeoPackage be fast? Yeah, Bernie. Basically, where should you store the data if all you're doing is like pumping it through something like GeoServer? I don't know. Is it going to change? That's what I always ask clients. Is the data going to change? Yes, it's going to change. Do you want to, SSH into a server and get rid of a geo package or replace a geo package? Or do you want to just open up QGIS and use the tools within to basically update the data set? It's really up to you. I really like keeping things within PostGIS. I think it's just an easy way of managing things. We have a lot of clients who use web-based GIS that we've built. And yeah, it's nice. They can edit something within QGIS and immediately see the results on the web because they're sharing out the data set directly from the database. Is a layer symbology saved by QGIS in the PostgreSQL table, or do we create such a table? This is a good question. Yeah, that's actually saved within QGIS. It's one of the wonderful integrations that we have within QGIS. Check out a couple of my other webinars on that subject, but yeah, you can save default symbology directly within the database. So open it up, press save to database, save it as the default symbology, and then whenever you load a data set, it will load. What QGIS does is it creates a new table within the public schema and saves the style as a separate row within that table. Question. Okay, what about encrypted connections between QGIS? How do we ensure a double check that? Yeah, we can do encrypted connections between QGIS and PostGIS. We do that on all of our servers. We have SSL required on all of those connections. For geospatial SaaS projects, basically, can QGIS be used for SaaS DB management? Not sure. Sorry, question about SaaS projects. I'm not sure what that refers to specifically. To keep track of all changes in a table, have you experimented with table version control? Was it a difficult process? I get asked about version control, I think, every time I talk about PostGIS. It's a great question, George. So yes, have I experimented? Yes. Do we use it in production? Yes. It's not really table version control. I've done a lot with audit tables, kind of different, but the same in a way. So an audit table will basically create a row in a separate audit table for every change that takes place on a data set. It's a nice way of tracking any changes that take place on a table in a separate table, so you can restore a little bit easier, but there's some work that has to be done in order to restore. It's not a simple button to say make this happen. There's a couple of plugins that were neat within QGIS. I think some of them lost support over the years, and there's also a couple of other plugins and third-party and open source tools that you can use for this. I think one of the keys here is to always have really good backups in place. If you're doing daily, that's great. If for some reason your operation needs to have backups made multiple times in a day, then let's talk about that and set that up as an option. Can you generate metadata from PostGIS? Yes, you can, Ralph. Yeah, you can run pretty much any query you want within the database. You can pull out things like the CRS, the name of the data set, the extents, the bounding box, things like that can be pulled quite easily. Metadata is actually incorporated into QGIS. Metadata support for PostGIS is actually included now within QGIS. It seems like it still needs a little bit of work because it's not as clear cut when you save metadata. You'll see if you tinker with it. So if you have a PostGIS database, go into the metadata, go into the layers properties and go into the metadata and add some stuff and press save, and just make sure you have the ability to save metadata to your database. I'll do a webinar one day on metadata. It's something that I've been thinking about soon. So I'll get into it. If anybody's raising hands too, feel free just to like drop questions in here. I'll work my way. Wow, the questions are coming in, people. Holy moly. If I don't have time to get through all of these, I will reach out to you. All right, this is the last one. Okay. Yeah, multiple geom types. Yeah, you can have point, line, and polygon, but is it preferable to have, yeah, Christy, I keep it separate. I'll keep different tables for different geometry types. I've had I did this with, okay, so you can do this with, I created a custom audit table for a client once. Their big concern was the geometry, whether a point was moved here or moved there. So it was a very simple audit table to create where you stored the original point location, and then you stored, if you move the point, you store the new point. So you have like a before and after geometry stored. So that table, imagine, has two geometry fields, the before and the after geometry. So what was nice about that in QGIS, you can actually switch between those different geometries. So you can load the layer twice, and when you load it, it's like, which geometry field do you want to load? I'm like, okay, I want to load the old, and then you just call that layer old, and then you load the layer again. You're like, which geometry do you want? You say, I want the new, and you load the new. So then you have two layers. They're the same layer, but you two versions of the layer, let's say, loaded onto your map, and you can see the before and after, and then you can just use the ID field as your label or something, and then you can say, oh, look, point number 2 moved. So yeah, bottom line, Chrissy, there's ways of doing that. You can do that. It supports that. PG metadata plugin is awesome for metadata. Thank you. Yeah, that's the one that I was looking at recently. It's really neat. But yeah, we don't use that much in production yet, but it's on my to-do list of things that I need to experiment a little bit more in. QGIS is also, like I said, is incorporating a lot of that into the layer properties, which is great. It would be nice if you could just save it directly natively within QGIS without having to use a third-party plugin. But anyway. All right, so I will be following up with everybody here. A copy of this video is going to appear on our YouTube channel. So I just want to thank everybody for coming, and thanks for all the questions. This is really great. If I didn't answer anything, though, email address is here. Feel free to reach out to me. I'm always happy to talk about this stuff more. Have a great day, everyone.